In this video, we are going to be talking about an important concept called fuzzing. So let's get started. What is fuzzing and why is it important as a testing methodology for Solidity smart contracts? When you think of fuzzing, it's actually a terminology that was invented in the security world where fuzz testing or fuzzing is a black box software testing technique which consists of finding implementation bugs, right? What could be some of the potential errors that your code could encounter in the way it has been written using malformed or semi-malformed data injection in an automated fashion. I know this seems like a lot, right, as a definition, but the idea is that fuzzing or fuzz testing will send random data to your code to ensure that it's able to handle all different kinds of scenario. And this sending this random data, creating this random data, all of this happens in an automated fashion. Why do you want to do fuzz testing? The aim behind wanting to fuzz is so that that application is stressed to think of different scenarios that could potentially go wrong. And you want to extract unexpected behavior, resource leaks, or crashes as a part of your fuzz testing. Of course, unless you have written some very robust and solid code, right? Let's understand how fuzzing works, right? What is the life cycle of fuzzing? Thanks to Immune Bytes, and they have a great blog on it, which I'll be linking as a part of the reading material as well. Here is a quick sort of understanding of the cycle of fuzzing, right? The first is identification of target system. What do you want to test? In our case, it's going to be our Solidity smart contracts. You can actually even do fuzz testing for an entire dApp, but we are not going to go there as of now. Determination of inputs, right? So what kind of random inputs do you need to generate? It's not like every function is going to have the same inputs, right? Some functions may take addresses, some function may take a combination of uints, addresses, strings, and whatnot. So you determine what kind of inputs do you need to generate. And then you generate the fuzzed data, right? That is, once you determine the kind of inputs, you are going to create random values of those inputs, right? Using some algorithms. And then you execute the test with the fuzz data that you have generated and analyze the way the system behaves, right? Once you've executed the functions, you want to see how they respond to the fuzzing. And as you keep finding issues, you keep logging the issues, right? So this is essentially your steps of fuzz testing. Of course, much of this is going to be abstracted perhaps by the framework that you use, the tools and the tooling that you use. But you have to remember that, these are the steps that are happening when you're actually fuzzing. Why fuzzing, right? We have spoken about this, or you might have read about this as a part of the tutorial as well. But largely, one is fuzzing does not only identify a problem, right? I'm sure you'll be writing a lot of unit tests to figure out how your success path and failure paths behave. But it also shows the cause of the problem and how an attacker may interact with it in a real life attack, right? That's what attackers do. They try to create random inputs to your functions to try to break it, right? And fuzzing proves a vulnerability exists without having to sift through false positives, right? Again, this is not necessarily true in all the fuzzing frameworks or all the fuzzing software that you use, that you will not get false positives. But largely, yes, because what you're going to do is you're actually interacting with the function, right? So however the function behaves is how it will behave in real time as well. So you're less likely to get false positives. Fuzzing is fully automated and can run independently, right? So once you create your fuzzing script and let it run, it can run on its own standalone without you having to intervene, right? The last but not the least, it is highly useful for developers because especially in the context of Solidity smart contracts, where some of the smart contracts may have deal with a lot of funds, And you want to ensure that you go beyond the traditional security tools that are only going to point out maybe your typical flaws, right? Your fuzzers are going to show the result of the flaw. What will this flaw do to your program? What could be some potential effects? Like, will it drain all the funds? Is it able to transfer funds to an unknown address? Is anyone able to, manipulate and take funds out of the system? And it shows you that how impactful would it be to solve this problem, right? This is why fuzzing is considered as one of the things that you should not miss if you're looking to build a robust and secure application.